Ever wondered why numbers, tables, and charts are so integral to our understanding of the world around us? Well, the secret lies in a powerful process called statistical treatment. It's like a magic wand that transforms raw, unprocessed data into meaningful insights. Statistical treatment is a crucial step in data analysis. It's where we apply statistical methods to sift through the data, identify patterns, and draw conclusions. It's not just about crunching numbers. It's about making sense of those numbers. Consider it this way. Imagine you've just conducted a survey with thousands of responses. You've got a mountain of raw data, but what does it all mean? This is where statistical treatment comes in. It allows us to interpret the data, identify trends, and ultimately make informed decisions based on those findings. This process is not just limited to research. It plays a significant role in various fields like business and policy making too. For instance, businesses use statistical treatment to understand consumer behavior and market trends, helping them to strategize effectively. Similarly, policymakers use it to analyze demographic data, which aids in formulating policies that cater to the needs of the population. Statistical treatment also helps in dealing with the uncertainties that come with data. It allows us to measure the accuracy and precision of our findings, identify errors, and understand their impact on our results. Through tools like standard deviation and confidence limits, we can determine the reliability of our data. We can even test the significance of our findings and decide whether to accept or reject a result. Moreover, statistical treatment gives us the ability to quantify relationships between variables using correlation coefficients and coefficients of determination. This way, we don't just understand the what and how of our data, but also the why. Indeed, without statistical treatment, raw data would simply be a messy pile of information with no meaning. So the next time you see a chart or a table, remember the might of statistical treatment that lies behind it, turning raw data into meaningful insights. Accuracy and precision, two words that often come hand in hand. But do you know what they truly mean in the realm of data analysis? Let's unravel these concepts. Accuracy is all about how close a measurement is to the true or accepted value. It's hitting the bull's eye in a game of darts. Precision, on the other hand, is about the repeatability of your measurements. It's hitting the same spot over and over again, regardless if it's the bull's eye or not. In data analysis, both accuracy and precision are vital. High accuracy means your results are reliable, they reflect the real-world scenario. High precision means your methods are consistent, they can be replicated with similar outcomes. So next time you hear these terms, picture this: a dart game where accuracy is about hitting the bull's eye and precision is about consistency in hitting the same spot. Just remember, hitting the bull's eye is about accuracy, while consistency in hitting the same spot is about precision. Even the best of us make mistakes, and in data analysis, these mistakes are known as errors. Unwanted as they may be, these errors play a crucial role in our understanding of data. Let's delve into this a bit deeper. Errors are classified into two types: systematic and random. Systematic errors, as the name suggests, follow a system. They are predictable and can be traced back to flaws in the measurement process. Imagine a scale that's always off by a few millimeters. That's a systematic error. On the other hand, random errors are unpredictable. They pop up without warning and have no discernible pattern. Picture a gust of wind disrupting a measurement. That's a random error. These errors, whether systematic or random, can distort our data and lead us astray. But by recognizing and understanding these errors, we can refine our data analysis techniques and draw more accurate conclusions. Errors might be unwanted, but understanding them is key to refining our data analysis. How can we measure the reliability of our data? Enter significant figures and standard deviation. Significant figures, often the unsung heroes of data analysis, carry quite a bit of weight. But what are they exactly? In essence, significant figures are the digits in a number that carry meaningful information about its precision. They are crucial because they help us understand the level of certainty in our measurements. For instance, if we measure a length as 12.34 meters, we're implying a higher degree of precision than if we simply said 12 meters. The extra digits, the 0.34, are our significant figures, and they tell us how precise our measurement is. But significant figures are only one side of the coin. The other side is standard deviation. a term that might sound intimidating but is actually quite straightforward. Standard deviation is a measure that quantifies the amount of variation or dispersion in a set of values. In simpler terms, it tells us how spread out the numbers in a dataset are. A low standard deviation means that the values are close to the mean, while a high standard deviation means that the values are spread out over a wider range. So why do these two concepts matter? They're essential in assessing the reliability of our data. Significant figures give us a sense of the precision of our measurements, while standard deviation offers insight into the dispersion of our dataset. Together, they provide a comprehensive picture of the data's reliability. But remember, these are just tools. They don't provide definitive answers, but rather guide us towards more informed conclusions. They help us answer questions like how precise are our measurements? How spread out or concentrated is our data? In the end, it's about how confidently we can trust our data. Because when it comes to data analysis, confidence isn't just a feeling, it's a quantifiable measure. And that's the beauty of significant figures and standard deviation. They transform the abstract concept of confidence into something concrete, something we can calculate and interpret. In the end, it's about how confidently we can trust our data. How can we determine if our data analysis is statistically significant? This is a question that often haunts researchers and analysts alike. The answer lies in the concepts of confidence limits and tests of significance. Let's start with confidence limits. In simple terms, a confidence limit is a range within which we expect a population parameter to fall based on our sample data. These limits are not absolute, but rather a reflection of our confidence. For example, with a 95% confidence limit, we're saying that if we repeated our experiment 100 times, we'd expect the true population parameter to fall within our calculated range 95 times. Now, on to the test of significance. This is a method used to determine whether the result of an experiment is due to the variable we're testing or simply a product of chance. The most common test of significance is the t-test, which compares the means of two groups to see if they are significantly different from each other. If the p-value obtained from a t-test is less than our predetermined significance level, usually 0.05, we say the result is statistically significant. But what happens when a result is rejected? A result might be rejected if it falls outside the confidence limits or if it does not pass the test of significance. This could be due to an anomaly in the data, an error in the experimental setup, or simply because the hypothesis was incorrect. Rejection of a result, while disappointing, is an integral part of the scientific process. It helps us refine our hypotheses and improve our experiments. As we delve deeper into data analysis, we realize the importance of these concepts. Confidence limits guide us in setting the boundaries of our predictions. Tests of significance help us distinguish between true effects and random chance. And the rejection of a result prompts us to question, explore, and ultimately advance our understanding. Remember, statistical significance is the key to validating our results in data analysis. What's the correlation between ice cream sales and temperature? And how determined are these variables to each other? Let's dive into the world of correlation and determination, two fascinating concepts in data analysis that help us understand the relationships between variables. Imagine a hot summer day. As the temperature rises, so does the demand for ice cream. But is there a way to quantify this relationship? Enter correlation coefficient. The correlation coefficient, often symbolized as R, is a statistical measure that calculates the strength of the relationship between the relative movements of two variables. The values range between -1 and +1. A perfect positive correlation, a value of 1, means that as one variable increases, the other does too at a constant rate. On the other hand, a perfect negative correlation, a value of -1, means that as one variable increases, the other decreases. In our ice cream example, we'd expect a strong positive correlation between temperature and ice cream sales. As the temperature rises, so do ice cream sales. But how do we know if an observed correlation is reliable? This is where the coefficient of determination, often symbolized as R squared, comes in handy. The coefficient of determination is the square of the correlation coefficient. It tells us the proportion of the variance in the dependent variable that is predictable from the independent variable. In simpler terms, if we have an R squared value of 0.8 for our ice cream example It means that 80% of the variation in ice cream sales can be explained by changes in the temperature. That's quite powerful, isn't it? These two statistical measures, correlation and determination, are invaluable tools in data analysis, helping us to understand and predict trends and relationships between variables. They give us the power to decipher and predict patterns in a world full of data. So, the next time you see an ice cream vendor on a hot day, remember it's not just coincidence, it's statistics. So, we've embarked on a journey through the statistical treatment of data, but what does it all mean? In essence, it's a toolset that enables us to make sense of the data around us, from determining accuracy and precision, grappling with errors, to measuring the weight of significant figures and standard deviation. It's about finding confidence limits, testing significance, and understanding correlation and determination. Subscribe for more because you won't find me later. After all, in a world overflowing with data, those who master statistics hold the keys to understanding.